right, problem number 31. Given a regular octagon with a radius of 5 inches, draw the radius, then find the perimeter and the area. All right, so we have a radius of 5 inches. So I'm going to go ahead and draw that radius. And remember, a radius goes from the center of the figure to a corner. So that would be 5 inches. Said to find the perimeter and the area. I'm going to find the area first because that's easier. To find the area, I need to draw in another radius. So from the center to a different corner. That would also be 5 inches. And then I'm going to need the measurement of the central angle. How do we find the measurement of the central angle? Yes. We do 360 divided by the number of sides. How many sides does this shape have? 8 sides. 360 divided by 8 gives us 45. So 45 degrees for that angle. All right. We had 2 different formulas to be able to find the area of a regular polygon. We had 1/2 apothem times perimeter, or the other one that we had was 1/2 AB times the sine of angle C times the number of sides. Do we know the apothem of this shape? No. What do we know? The radius. We know the radius and we know the angle in between the 2 radii. Which of these 2 formulas would be easier for us to use right now? 1/2 AB times sine of C times N. We don't have the apothem, we don't have the perimeter, but we have everything we would need to plug into this one. All right, so let's go ahead and plug into that formula. So I have A equals 1/2. What goes in for A and for B? 5 and 5. Make sure that you substitute something in for each of those. When I was grading this test back a couple weeks ago, people were grabbing the radius, but they were putting one number in for 2 variables, like just a 5 instead of 5 and 5. You have to have something going in for each of those. Times the sine of what? Sine of 45. Very bottom one is this review. Times 8. And then we grab a calculator and we pop it in. What do we get? $70.711. Should we put units with that? Inches squared. Yes, this is area, so it gets squared units. So 70.711 inches squared. Yes. Yeah, if you wrote 70.71, that's perfectly fine. 70.71 would be fine. All right, now we need to find the perimeter. In order to find the perimeter, the first thing I'm going to do is up on my picture, I'm going to draw in the apothem. We're not going to find the apothem, but the apothem makes a right angle with the side of my octagon. So I'm going to redraw that triangle that I just have inside there. So here's the apothem. And then here's the radius. And here's half the side of the octagon. So apothem forms a right angle here. This is 5 inches. And this is half the side of the octagon. 22.5 is what? You're right. This angle right here. 45 over 2, because we took our central angle, the apothem, cut that in half. So we get 22.5 degrees. All right. Does anybody remember where we need to go from here? We can't do a squared plus b squared equals c squared because my problem is that I only have a number for one side. SOHCAHTOA. We're going to pull out SOHCAHTOA, which means I need to label my sides. Which side up here is the hypotenuse? The 5 inches, the radius. The apothem is which side? Adjacent. So this one down here is the opposite side. And that's actually what we want to find. We want that. We know this one. So when I look at SOHCAHTOA, which one of these lets me use the opposite and the hypotenuse? So, because we don't have nor are we interested in the adjacent side. All right, so sine of 22.5 degrees equals opposite over hypotenuse. What's my opposite side? 1/2 side. It's 1/2 the side of the octagon. And my hypotenuse is 5. Where would I go from here? Times both sides by 5. Yes, we're going to multiply by our denominator of 5. What is 5 times the sine of 22.5? 1.913 is equal to my half side, but I don't want half the side, I want the whole side. So what do I need to do to this to get rid of that 1/2? Multiply by 2. If you do it to one side, you got to do it to the other side. That 2 cancels my denominator out, so now I just have one side is 3.826. So this right here is what I want to use to find the perimeter. What do I do with that 3.826 now? Times it by the number of sides. Remember, the perimeter is equal to the number of sides times the length of each side. How many sides do we have? 8 sides times 3.826. What'd you get? 30.608. Should we put units with that? Inches. Inches or inches squared? Just inches. 30.608 inches. Very nice work. What else would you guys like to see? 33, absolutely. Yes. Yep. But 33 is the next one that we will go to. You good, Essen? Okay, let's go look at 33 then. The area of a kite is 120 feet squared. If one diagonal is 12 feet, find the other diagonal. So I'm going to need the area formula for a kite because they gave me the area. If this is not on your cheat sheet yet, I would absolutely make sure to get all of my area, volume, and surface area formulas. How do you find the area of a kite? 1/2 diagonal 1 times diagonal 2. Yes. That also works for what other shape? Not just a kite, but a rhombus. Absolutely correct. All right, so we're going to take this 120. It's going to take the place of A. So I have 120 equals 1/2. In the place of the first diagonal, I'm going to put the 12 feet. And then the other one we just leave as a variable, diagonal 2. I want to get rid of the 1/2. And a lot of times I would multiply both sides by 2 to get rid of the 1/2. But an easier thing to do here is to just find half of 12. 6. So I would have 120 equals 6 times diagonal 2. And then what? Divide by 6 on both sides. What is 120 divided by 6? What is it? It is 20. I couldn't hear you. It is 20. Should we put units with that? Feet or feet squared? What did we just find? We found area. We found a diagonal. We were given the area. So my answer doesn't have a squared because this isn't what we found. We were given that piece. So it's just feet. Yes. Got somebody in front of you. Yes, you may go now. When he comes back, you may go. What else would you guys like to see? With 36? Absolutely. Let's go look at number 36 on the next page. A farmer wishes to paint the outside of his silo. Do you guys know what a silo is? A silo is found on a farm, usually somewhere near a barn, and they use it to store grain in. That's what a silo is. And they've got one drawn over here. Sometimes it has a cone shape on the top, sometimes it has a dome shape on the top, but it always has this cylinder shape to it. Find the total amount of square feet that needs to cover the silo. The bottom base of the silo is on the ground and would not be painted. If I want the total amount of square feet that we would paint on the outside of this figure, what are we asking for? Surface area. What do I need to find the surface area of? The cylinder and the cone, yes. So we need the surface area for the cylinder together with the surface area for the cone. All right. So what's the surface area formula for a cylinder? That's my volume, but that's close. Pi r squared times height would give me volume. How do I find surface area? 2 pi r squared. Nope, that's volume. Plus 2 pi r times height. There we go. 2 pi r squared finds the area of what? The circle. How many circles are in a cylinder normally? 2. How many of those circles would be painted on this silo? Which one? The one on the bottom? The bottom base is on the ground. We wouldn't paint on the ground. So none, yeah. So we don't need this part. On the top circle, we have a cone sitting there. So the circle part is actually on the inside now, not the surface. The bottom one is on the surface, but it's not going to be painted because it's resting on the ground. Okay, so for our cylinder, we just need 2 pi RH. What is the surface area formula for a cone? What's our surface area formula for a cone? Yes, there's more to the whole formula. It'd be pi r squared plus pi r times the slant height. Are we going to paint all of a typical cone? No. What part of the cone are we not going to paint? The circle. Which part of this formula is the circle? The pi r squared part. So you were right, pi r times the slant height is the only part that we need to include that would be painted here. All right. Do we know what r is? Radius, and it is 4. From here to here, that's my diameter, that's 8. So the radius would be 4 meters, and that's the radius for both the cylinder and the cone. So let's go ahead and substitute in. We have 2 pi times 4 times the height of the cylinder. What is the height of the cylinder? 14. This right here is the height of the cylinder. Well, if that's the height of the cylinder, what's the height of the cone? 6. How'd you get that? 20 minus 14 gives us 6. That is the height of the cone. Do I need the height of the cone for the next part of the formula? What do I need, though? I need the radius and the slant height. Do we know the slant height? No. This right here would be the slant height. What are we going to have to use to find the slant height? Pythagorean theorem. A squared plus b squared equals c squared. What has to go in for c? Slant height. Slant height always goes in for c. C is not always what you're looking for. C is the slant height. All right, what goes in for A and for B? 4 and 6. 6 and 4. Does it matter which one goes where? Nope. We're going to take both of those numbers and square them. So that would be 36 plus 16 equals slant height squared. What is 36 plus 16? 52 equals my slant height squared. Then we take a square root of both sides. Over on the right, the squared and the square root cancel each other out, so I have just the slant height. What is the square root of 52? 7.211. So that's what we're going to substitute in over here. 7.211. And then I take that whole thing and I pop it into my calculator. All of this here. What do we get? $442.474. Should we put units with that? No. Meters squared. This was in meters here. All right. Find the total amount of grain that will fit in the silo. What am I asking for now? The volume. So once again, I'm going to need volume of the cylinder plus volume of the cone. How do we find volume for the cylinder? How do we find volume for the cylinder? Pi r squared times height. Plus, what about volume for the cone? What'd you say? We are going to use a pi r squared, not 2 pi r squared, times height. That's exactly the same as the cylinder. There is a difference between the cylinder and the cone formulas. 1/3. A cone is 1/3 the volume of a cylinder with the same radius and height. All right, so I have pi times, what's the radius of the cylinder? 4. So pi times 4 squared times, what's the height of the cylinder? 14. So pi times 4 squared times 14 plus 1/3 pi times, what's the radius of the cone? Radius of the cone is 4 times the height of the cone, which is 6. You're right. And then we pop that whole thing into our calculator. And we get what? (2477). Let's round that up to 248 then. And that would be meters cubed. Nicely done. What else would you guys like to see? (37), absolutely. You guys okay if I scoot on to number 37? Find the volume and surface area of the pentagonal prism. All right, so let's do volume first. What is the volume formula for a prism? Area of the base times the height. What shape is the base? Close. Pentagon. It says pentagonal prism. Pentagons have 5 sides, hexagons have 6. Yep, that's okay. Okay, so we need the area of a pentagon times the height. How do we find the area of a pentagon? 1/2 AP, 1/2 apothem times perimeter times the height. Do we have the apothem of the hexagon? Yes. How big is it? 7.6. This right here is the apothem. So times 7.6. Do we have the perimeter? No. Can we find the perimeter? How big is a side of the pentagon? 11. We see that right here. So this side over here, because it's got a congruence mark on it, would also be 11 feet. This side here would be 11 feet. This side would be 11 feet. And up here would be 11 feet. So what is our perimeter? 55. Number of sides times the length of each side. 5 times 11 gives us 55. So 1/2 times 7.6 times 55 times the height of the prism. What is the height of the prism? 12. So then we grab our calculators and we pop all that in. 2508. Should we put units with that? Feet cubed. 2508 feet cubed. Now we also need to find the surface area. What's the formula for the surface area of a prism? Nope. Base times height is how we find the area of a parallelogram. How do we find surface area for a prism? No? Yes. 2 times the area of the base plus the perimeter times the height. Yes. All right, so we're going to do 2 times 1/2 AP, because that's how we find the area of the base, plus the perimeter times the height. So I have 2 times 1/2 times, what was our apothem again? 7.6 times the perimeter, what was that? 55. Plus the perimeter of 55 times what? Times 12. Got it all squeezed in there. What does that come out to? $1078, 1,078, and that would be square feet or feet squared. What else would you guys like to see? 35, absolutely. Let's go back and do number 35. Find the area of the triangle. So there's 2 formulas that we had for the area of a triangle. We had the one that you guys learned before you ever got to geometry, 1/2 base times height. Or we have the new one that you learned here, 1/2 AB times the sine of angle C. Which one should we use here? Second one, the one with sine. A and B both have to be what on the triangle? They have to be sides. And C has to be what? Yes, this is the angle between A and B. What do we have to use for A and for B here? 20.8 and 34.5. We know 2 angles. There's a third angle that we don't know. Do we need to go and find that third angle? So which of the 2 angles do we use? 37, because it is in between the 2 sides that we have. All right, so now we take that and pop it into our calculators. You said 0.93 what? 931. Should we put units with that? No. I could put units squared if I wanted to. It's area, so it would get squared units, but I don't have to put that part. Have time for between 2 and 3 more questions, depending on how long they are. What else would you guys like to see? 42? Absolutely, we can go and do number 42. Identify the shape of the cross section if sliced parallel and perpendicular to the base. So this would be a cross section that is parallel to the base. And if I cut it like that, it will be the same shape as the base. What shape is the base? A hexagon. So if we slice parallel to the base, we're going to get a hexagon. perpendicular to the base, I'd be going this way. And our options when we are perpendicular to the base are rectangles, triangles, circles. If I cut this perpendicular to the base, what shape would I see on that cut side? A rectangle. Remember, when we're talking about cross sections, a cross section is a flat, two-dimensional shape. None of the shapes that we studied in 11B, cones, cylinders, spheres, those can never be cross sections. Those are things we are cutting and looking at the cross section, but I can't cut a solid and end up with another solid. I cut a solid and I see a cross section of a flat, two-dimensional shape. What else would you guys like to look at? Which one? 23, absolutely. Problem 23, right here, says find the value of x. So we have two angles that are inside the circle. We have this angle here, and we have this angle here. Those are vertical angles and they are congruent to each other, which means they're both how big? They are both 65 degrees. Now, the formula that we had when we studied this back in Module 10 is that the measurement of the angle is equal to 1/2 the sum of the two arcs. So arc plus arc. So in the place of the angle, we're going to put 65 equals 1/2. And now we need the intercepted arcs. This is one of my intercepted arcs, and that's how big? 50. So inside my parentheses, I start with a 50 plus, how big is the other intercepted arc? 20x, this one right here. So 50 plus 20x. And we want to solve this for x now. I need to get rid of this 1/2 out in front here. I've got two different ways I could get rid of it. I could distribute that 1/2 inside. These are both numbers that it's easy to find half of. Or I can just get rid of the fraction entirely by doing what? Multiply by the denominator. We can multiply both sides by 2. That makes my denominator cancel out, and the 2 out here goes away. So then I have 2 times 65, which is 130, equals 50 plus 20x. What would I do now? Subtract 50 from 130. What is 130 minus 50? 80 equals 20x. Then we divide both sides by 20. And we get that x is what? X is 4. I have time for one more question. What else would you guys like to see? 24? Absolutely. Number 24, find the value of x, assuming lines that appear to be tangent are tangent. A tangent to a circle is a line that touches it in exactly and only one spot. So this top line right up here, that segment touches my circle in this one spot only. This is a tangent. Same thing is true for this line segment down here. It touches my circle in exactly 1 point, so this is also a tangent. Those two tangent lines meet right here in a common endpoint. Does anybody remember when I have two lines that are tangent to a circle that have a common endpoint? What is the relationship between those two segments? They are congruent. And what do we do with segments that are congruent? Set them equal to each other. So 2x minus 5 equals x plus 6. Then we're going to solve this for x. So I'm going to get my x's on the same side first. I have 2x minus x. That gives me 1x minus 5 equals 6. Then I add 5 to both sides. And what is 6 plus 5? 11. X is equal to 11. Nicely done. You said 25? I think I have just enough time for 25, actually. On number 25, we've been asked to find the measurement of angle SXW, this angle right here. That is an inscribed angle. And the rule that we had for that when we were studying circles is that the measure of the angle is equal to half the measure of the arc. So if I knew how big this arc was right here, I could cut it in half and I would know how big the angle is. Do I know how big the arc is? No. But I do know a couple of the angles in here. This is also an inscribed angle. And how big is that angle? 64. It intercepts this arc right here. So how would I find that arc? The angle is half as big as the arc. Not divided by 2. That's if I had this one. Times 2. 64 degrees times 2. So this arc over here is 128 degrees. There is another angle that I have. I have this angle over here, which is 36 degrees. And I can use that to find this arc. How would I find that arc? Times it by 2. 36 degrees times 2 gives me 72 degrees. If I go all the way around the circle, it's how much? 360. Well, I know all of the circle except for this piece up here that I wanted. So what could I do to find it? $128 plus 72, and then do what with that number? Yes, 360 minus whatever we get from doing this. So that's 128 plus 72. What is 128 plus 72? 200. So I have 360 minus 200. What's 360 minus 200? 160. So that's this arc up here. So I can take and plug in 160 degrees for the arc. And I need half of that for the measurement of my angle. What is half of 160? 80. So that angle is 80 degrees. All right, and now I'm out of time. I don't have time to do any more. Monday, I'm still more than happy to answer any questions that you have. I'll answer them individually instead of leading from up at the front, but you've got Monday and Tuesday to ask questions and to work on your cheat sheet. Answer key for the test review is already posted in Canvas, and don't forget, you will be turning in this final exam review packet the day of your exam. So you'll turn this in next Thursday. When do you turn in your cheat sheets? Cheat sheets are turned in on Tuesday. Cheat sheets get turned in on Tuesday. Review packet gets turned in on Thursday.